What happens inside your body over time is not random, and it is not sudden. Aging unfolds in phases, quietly reshaping biology decade by decade, while outward life continues as usual. The most important changes are not the ones you see in the mirror, but the ones taking place beneath the surface, inside cells, tissues, and systems that slowly adapt, compensate, and eventually decline. Each decade leaves a biological imprint, altering how your body produces energy, repairs damage, responds to stress, and maintains balance. In the 20s, the body appears to be at its peak. Strength is high, recovery is fast, and resilience feels unlimited. Yet internally, subtle changes begin. Cellular repair systems are still strong, but they are no longer operating at maximal efficiency. Mitochondrial energy production starts its first gradual decline. DNA repair remains effective but slightly less precise than in adolescence. Hormonal signaling stabilizes after developmental surges, setting the baseline for adult physiology. These changes are not harmful on their own, but they mark the transition from growth-driven biology to maintenance-driven biology. The body is no longer optimizing for expansion, but for preservation. During the 30s, compensation becomes the dominant theme. The body works harder to maintain the same outward performance. Cellular turnover slows modestly. Collagen production decreases, even though skin may still look youthful. Muscle protein synthesis becomes more dependent on stimulus and recovery. Low-grade inflammation begins to rise in many individuals, not enough to cause illness, but enough to subtly affect tissue repair. Metabolic flexibility starts to narrow, making the body less forgiving of poor sleep, chronic stress, and excess nutrition. These changes remain largely invisible, which is why the 30s often feel deceptively similar to the 20s. The 40s represent a critical inflection point. Reserve capacity begins to shrink. Mitochondrial inefficiency becomes more noticeable at the cellular level, reducing energy availability for repair and regeneration. Hormonal signaling changes more clearly, affecting muscle maintenance, fat distribution, skin thickness, and bone turnover. DNA damage accumulates more visibly in tissues, and repair mechanisms slow further. Chronic inflammation becomes more entrenched, shifting the immune system toward a state of constant low-level activation. This is often the decade when the body starts responding differently to stress, recovery takes longer, and subtle health issues emerge. In the 50s, structural decline accelerates if compensatory systems are overwhelmed. Collagen loss becomes more pronounced, affecting skin, joints, and connective tissue. Bone remodeling shifts toward net loss, increasing fragility over time. Muscle mass declines more rapidly without intentional maintenance. Mitochondrial dysfunction spreads across tissues, reducing endurance and metabolic efficiency. Cellular senescence increases, meaning more cells stop functioning properly but remain active, secreting inflammatory signals that damage surrounding tissue. These processes interact, creating feedback loops that accelerate biological aging. The 60s mark a shift from compensation to vulnerability. Organ systems operate with significantly reduced reserve. The immune system becomes less responsive to new threats while remaining chronically inflamed, a pattern known to increase susceptibility to infection and chronic disease simultaneously. Tissue regeneration slows further as stem cell activity declines. Blood vessels lose elasticity, impairing circulation and nutrient delivery. Neural processing speed decreases as energy availability in the brain declines, and cumulative damage affects communication between cells. These changes do not occur uniformly, which is why aging appears so different from person to person. In the 70s and beyond, aging becomes increasingly system-wide. Cellular damage accumulated over decades now affects organ-level function. Mitochondrial energy deficits limit repair capacity across the body. Inflammation contributes to tissue breakdown rather than protection. Protein quality control weakens further, allowing damaged proteins to accumulate and disrupt cellular signaling. The body becomes more sensitive to stressors that were once easily tolerated. Recovery from illness, injury, or surgery slows dramatically, because repair mechanisms are no longer able to respond quickly or efficiently. What is often misunderstood is that these decade-based changes are not strictly determined by age alone. They reflect how much damage has accumulated and how well repair systems have been preserved. Two people entering the same decade can have profoundly different internal states. One may still operate with biological systems resembling someone much younger, while the other may experience accelerated decline. The difference lies in the balance between energy production, inflammation control, DNA repair, metabolic health, and cellular resilience maintained over the previous decades. Scientific research consistently shows that biological aging progresses unevenly. Periods of stability are followed by periods of accelerated change, particularly when compensatory systems fail. Aging is not linear. It advances in steps, with each decade revealing the consequences of what has accumulated silently before. This is why health can appear stable for years and then decline rapidly within a short window. The most important insight is that every decade builds upon the last. The biological state of your 40s is shaped by what happened in your 20s and 30s. The trajectory of your 60s reflects how well your body managed inflammation, energy, and repair earlier in life. Aging is cumulative memory written into cells over time. What happens inside your body every decade is not fate. It is biology responding to accumulated stress, damage, and adaptation. Aging does not suddenly arrive at a certain age. It reveals itself gradually, decade by decade, as the body's ability to compensate finally gives way to the history written into its cells.